subscribe now and press the bell icon. Never miss an update.
Well students, in the last class we solved some problems on types of functions. Today we shall discuss some more problems. Here is the question. Prove that the greatest integer function f from R to R given by f of x equals x enclosed by square brackets is neither 1 to 1 nor onto, where x enclosed by square bracket x denotes the greatest integer less than or equal to x. See, here we need to show that where the given function is neither 1 to 1 nor onto. So to prove that, we need to examine whether the function satisfies 1 to 1 or onto conditions. If it satisfies, then it is 1 to 1 or onto. If not satisfies, then it is not 1 to 1 or onto. See, in the last year, you know about the greatest integer function given f of x equals a greatest integer function x. See, just we shall draw the graph of the function where it is. This is what step function. Here, if you take f of 1.3 where it is equal to 1, 1.3 is equal to 1. If you take f of 1.9, that will be 1. Means f of 1.3 equals f of 1.9 equals 1. But 1.3 is not equal to 1.9. Clearly, it is not satisfying the condition of 1 to 1. So, to say the function is 1 to 1, if f of x1 equals f of x2, imply x1 equals x2 for all x1, x2 belongs to domain. Here the domain elements are 1.3, 1.9, whose image is 1. Distinct elements of domain having same image in codomain, hence f is, therefore f is not 1 to 1. F is not 1 to 1. Now to verify the onto condition. See, in real numbers, where domain is real number, codomain is also set of real numbers. One, two, three, and etc. Here also -1, -2, -3, 1, 2, 3, etc. Greatest integer means only it map with the integers only. Between the value of 0 to -1, or between the number 0, -1, or between the two numbers, there are infinitely number of real numbers. So none of those real numbers or p by q numbers are not having any pre-images in domain. Hence we will say the function is not onto. Instead of that, if we say since 1 by 2 has no pre-image in domain, therefore f of x is not onto. Thus f of x is neither 1 to 1, nor Since 1 by 2 has no pre-image, see, we have written only what? Pre-image, no pre-image in domain. Therefore, f of x is not onto. Since it is not 1 to 1 and onto, therefore it is neither 1 to 1 nor onto. So this is how we can show that the given function is neither 1 to 1 nor onto. Just examine the condition whether it satisfies or not. Satisfies, it is 1 to 1 or onto. If not, it is neither 1 to 1 nor onto. We shall discuss one more example. Here we need to show that the modulus function f from R to R given by f of x equals mod x is neither 1 to 1 nor onto, where mod x is x if x is positive or x, and mod x is minus x if x is negative. We shall take the given function. Given f of x equals x if x greater than 0, greater than or equal to 0, minus x if x less than 0. See, if you take minus 1, where image of minus 1 is 1, even if you take 1 whose image is also 1, but minus 1 not equal to 1, therefore f is not 1 to 1, f is not 1 to 1. If you draw the graph of the mod function, where it is in the shape of vectoring, if you draw any line parallel to x-axis where that line cuts the graph of the curve of the function at 2 points, means distinct elements of domain are having same image in codomain. So it is not satisfying the condition of 1 to 1. Therefore, that function is not injective. 1 to 1 is also called as what? Injective. Therefore, f is not 1 to 1. Now, to examine the onto, take any negative element. 0, minus 1, minus 2, minus 3, 1, 2, 3. 1, 2, minus 1, minus 2, minus 3, 1, 2, 3. Where f is a function from R to R. None of the negative element be the or none of the negative element of codomain are not the image of any element of domain. Which means you take any negative element from the codomain for which we do not find any pre-images in domain. If you show at least one of the element doesn't have pre-image in domain, it is sufficient to say that function is not onto. Here we have plenty of numbers, so those are not having any pre-images, which means range is not equal to codomain. When the range is not equal to codomain, then we say that function is not onto. Since minus 2 has no pre-image in domain, hence f of x is not onto. Since minus 2 has no pre-image in domain, hence f of x is not onto. Which means here what? Range is not equal to codomain. Range is not equal to codomain. When the range is not equal to codomain, clearly we will say that function is not onto. Since the function is not 1 to 1 nor onto, hence thus f of x is neither 1 to 1 nor onto. See, here we have discussed two functions. One is greatest integer function, another one is modulus function. Here both are neither 1 to 1 nor onto. So student, here we need to show that the signum function f from R to R given by f of x 1 if x greater than 0, 0 if x is equal to 0, minus 1 if x less than 0 is neither 1 to 1 nor onto. In the previous two examples we have seen where the greatest integer function and mod functions are neither 1 to 1 nor onto because they are not satisfying the conditions of injectivity and surjectivity. Likewise, here also we will examine whether this signum function satisfies the conditions of injectivity and surjectivity. So now consider the given function. Given f of x 1 when x is greater than 0, 0 when x is 0, minus 1 when x is less than 0, less than 0. So you also learned the graph of these functions in first PU. Now, if you take any two arbitrary elements from positive arbitrary elements from domain, say f of 1 equals f of 2 equals 1 for any positive element of x where signum function is 1. So mapping with 1 only. If x is 1, 2, 3 and so on up to n, then what is the value of y? Y is only 1. Likewise, if you take x as minus 1, minus 2 and so on to minus n, where y is minus 1 only. Y is minus 1. Means image of any negative elements of domain whose image is minus 1. For any positive element of domain whose image is plus 1. So here we have taken two distinct elements from domain, 1 and 2. Its image is 1. So this implies, that is, since 1 is not equal to 2, 1 is not equal to 2, distinct elements of domain are having the same image, which is contrary to the definition of injectivity. Therefore, f is not 1 to 1. F is not 1 to 1. Not 1 to 1. You know the graph of the function. By that also you can refer where the line parallel to x-axis meets the curve at many points. Therefore, it is not 1 to 1 or injectivity. For onto, if you show at least any one of the element as not having any pre-images in domain, it is sufficient to say it is not surjective. You take 2, since 2 as no pre-image in domain, since 2 has no pre-image in domain, where 2 belongs to what? Codomain, as no pre-image in domain, therefore range is not equal to codomain. Range is not equal to codomain. Hence f is not onto. F is not onto. Thus f of x is neither 1 to 1 nor onto. So with these examples, I hope you have learned how to check up the injectivity and surjectivity of a function, or 1 to 1 and onto of a function. Now here is one more example. Let A be the non-empty set whose elements are 1, 2, 3, B be the set whose elements are 4, 5, 6, 7, and they have defined a function f as a set of all ordered pairs 1, 4, 2, 5, 3, 6 be a function from A to B, so that f is 1 to 1. Given where f is 1, 4, 2, 5, 3, 6, which means f of 1, image of 1 is 4, image of 2 is 5, and image of 3 is 6. What are 1, 2, 3 are the elements of a set A. What are 4, 5, 6 elements of B. Look at here, distinct element of domain are having distinct images in codomain. Since distinct element of domain are having distinct images in codomain, clearly it is satisfying the conditions of f of x1 is equal to f of x2 imply x1 is equal to x2, or f of x1 is not equal to f of x2 imply x1 not equal to x2. Hence the function is 1 to 1. So clearly distinct element of A, clearly distinct element of A are having distinct images, in B, hence F is 1 to 1. F is 1 to 1. So here they have given two non-empty sets A and B, and F is defined from A cross B to B cross A as f of A B is equal to ordered pair B comma A is bijective function. We need to examine whether this function is bijective or not. Given f from A cross B to B cross A and f of AB equals B comma ordered pair B comma A. Consider to check up the injectivity. Consider f of A1 comma B1 equals A2 comma f of A2 comma B2 for all A1 comma B1 and A2 comma B2 belongs to A cross B. See, by the defined way where f of AB is ordered pair B comma A, then obviously f of A1 comma B1 is ordered pair B1 comma A1, where f of A2 comma B2 is ordered pair B2 comma A2. This implies we know that two ordered pairs are equal only when their corresponding elements are equal. In an ordered pair B1 A1, B1 is the first member, A1 is the second member. Similarly, in an ordered pair B2 comma A2, B2 is the first member, A2 is the second member. Two ordered pairs are equal only when their corresponding elements are equal. So B1 is equal to B2 and A1 equals A2. This implies A1 comma B1 equals A2 comma B2. We can write down because here we have taken two ordered pair when they are equal. Since A1 is equal to A2 and B1 is equal to B2, here also it is satisfying the conditions of equality of two ordered pairs, where f of A1 B1 equals f of A2 B2 is giving A1 comma ordered pair A1 B1 and A2 B2. Therefore f is 1 to 1 or f is injective. Now for onto. For any ordered pair B comma A belongs to B cross A, there exists an ordered pair A comma B belongs to A cross B. You take any ordered pair from the codomain. We will find pre-images in domain. Therefore, that is range equals codomain. When range is equal to codomain, clearly that function is surjective. Therefore, f is onto. Since f is both 1 to 1 and onto, hence the given function is bijective. Thus f is bijective. In bracket you can write because f is both 1 to 1 and onto. So this is how we can examine or we can justify that the given function is bijective. Here we have one more problem where f is a function defined from n to n, where the f of x is defined as n plus 1 by 2 when n is odd, n by 2 when n is even for all n belongs to set of natural numbers. State whether the function f is bijective. Justify your answer. Here we need to examine whether the function is one-to-one or onto. If it is one-to-one and onto, then clearly that function is bijective. If not, then it is not bijective. Let's check up whether it is bijective or not. Consider the given function. Given f of x equals n plus 1 by 2 if n is odd. N is odd. N by 2 if n is even. N is even. For all n belongs to n. N belongs to n. Now, f of 1 equals 1 plus 1 by 2 equals 2 by 2 equals 1. If you take f of 2, when n is even, then f of x is defined as n by 2. In place of n here we have 2. Replace that n by 2, 2 by 2, and that will be equal to 1. Here we have taken the distinct element from the domain, but we are getting the same image in codomain. So this implies f of 1 equals f of 2 equals 1, but 1 is not equal to 2. Means it is contrary to the definition or conditions of 1 to 1. Therefore, f is not 1 to 1. F is not 1 to 1. F is not 1 to 1 or not injective. Now for onto. See, here we have two cases. One is when n is odd, and another case is when n is even. Case for onto, case 1. If n is odd, therefore n equals 2r plus 1 for some r belongs to, for some r belongs to n. Then there exists a number, natural number exists 4r plus 1 such that f of 4r plus 1 equals, in place of n, replace it by 4r plus 1, 4r plus 1 by 1 plus 1 by 2, and that will be equal to 2 times of 2r plus 1 by 2, that will be equal to 2r plus 1 when n is odd. So we are getting, there exists a number 4r plus 1. Where we are getting that 4r plus 1? We are getting that 4r plus 1 in domain. And for each odd elements in codomain, we have a corresponding pre-images in domain. So 2r plus 1. Now the case 2, if n is even, when n is even, therefore n will be what? 2r. For some r belongs to n, there exists a number, 4r such that f of 4r equals, when n is even, it is n by 2, 4r by 2, that will be equal to r, that will be equal to r. Means for any even number in codomain, we have a corresponding pre-images in domain. So codomain is equal to range. Therefore the function f is onto. F is not 1 to 1, but it is onto. It is not both. Therefore it is not bijective. The given function is only 1 to 1, but not onto. They have given a condition here that f is a function from R to R defined by f of x equals 3 minus 4x, and in the second one where f is function from R to R defined by f of x equals 1 plus x square. We need to state whether the function is 1 to 1 or 1 to 1 onto or bijective. 1 to 1 onto or bijective. So you are already familiar with the conditions of 1 to 1 and onto, or injectivity and surjectivity. We just check up whether the given function, defined function, is satisfying the conditions of 1 to 1 and onto. For the first one, consider or given f of x equals 3 minus 4x for all x belongs to domain set R. Here both domain and codomain are what? Set of real numbers. But x is taken from domain set. Okay. Consider f of x1 equals f of x2 for all x1, x2 belongs to domain. So where f of x is 3 minus 4x, then f of x will become 3 minus 4x1. Where f of x2 is 3 minus 4x2, that 3 get cancelled. Then we have minus 4 cancel means transfer the 3 to left side, where it become 3 minus 4x2 minus 3. Then we in the LHS we have only 4x1, whereas in RHS we have minus 4x2. Now that minus 4 get cancelled, x1 is equal to x2. Where f of x1, f of x2 implying x1 equals x2 means satisfying the condition of injectivity are 1 to 1. When it satisfies the respective condition, obviously that function is 1 to 1. Therefore, f is 1 to 1. F is 1 to 1. Now to check up the onto, we shall choose any arbitrary element from the codomain. Let y belongs to R. Say codomain. Let or any arbitrary element y belongs to codomain. Let y equals f of x. Then y equals, where f of x is what? 3 minus 4x. Solve for x, where it is 4x equals 3 minus 5. Then x equals 3 minus 5 by 4. Consider f of 3 minus 5 by 4. That will be 3 minus 5 by 4. We have 3 minus 4. Wherever x replace it by 3 minus 5 by 4. Simplify. 4. We have 3 minus 3 plus 5, and that 3. We have what? Y. Means for each element in codomain having pre-images in domain, means range is equal to codomain. Range equals codomain. When range is equal to codomain, clearly that function is onto. Therefore, f is onto. Since f is both 1 to 1 and onto, hence f is bijective. This is how where we can prove that the given function is bijective or not, just by verifying the condition. Now the second sum, f is different from R to R, where f of x is 1 plus x square. Given f of x equals 1 plus x square for all x belongs to R, domain set of real numbers. Consider f of x1 equals f of x2, where x1, x2 belongs to domain, where f of x1 is 1 plus x1 square, where f of x2 is 1 plus x2 square. Simplify. x1 square equals x2 square. Since set of real numbers, x1 equals plus or minus x2, means not satisfying the condition of 1 to 1. Therefore, f is not 1 to 1. Not 1 to 1. Whenever it is not 1 to 1, you can also prove it by just by giving counter example. Like f of minus 1 equals f of 1 equals 1, but minus 1 is not equal to 1. By example, by counter example, in place of x, replace them x1, x2 by particular value, like minus 1 and 1, whose images is 1 only. Though they are distinct elements, they are having same image, means not satisfying the conditions of 1 to 1. Therefore, that function f is not 1 to 1. Therefore, f is not 1 to 1. Now for onto, let y belongs to codomain. Y belongs to R, say where R is from codomain. Y belongs to R. let y equals f of x, where f of x is 1 plus x square, and by that x square equals y minus 1, or x equals square root of y minus 1. If y is greater than, if y is less than 1, then x does not belongs to set of R. X does not belongs to set of R. Means for some elements of codomain are not having pre-images in domain, which means thus range is not equal to codomain. Therefore f is not onto. To take some counter example, take minus 2. Y equals minus 2. If y is minus 2, whose preimage does not exist in domain, therefore it is not onto. Since minus 2 has no pre-image, like that you take any negative element, for that we do not find any pre-images. Here I am taking only one element, like minus 2. Since minus 2 has no pre-image in domain, hence f is not onto. Since the given function is not 1 to 1 and onto, therefore it is neither 1 to 1 nor onto. First, now we will see some objective type questions. Here we have a question. A f is defined from R to R as f of x is equal to x power 4. We need to choose the correct answer. Means in the given options we need to choose the correct. They have given that f is 1 to 1 onto, f is many 1 onto, f is 1 to 1 but not onto, f is neither 1 to 1 nor onto. So far we have solved many problems regarding 1 to 1 and onto. So if the function satisfies the respective condition, obviously we will say that function is 1 to 1 onto. If it is both 1 to 1 and onto, then it is bijective. Here the given function is what? F of x is equal to x power 4. So if you take f of minus 1 and f of 1, clearly the image is 1. Distinct elements are having same image, therefore it is not 1 to 1. It is not injective. Like that if you take for the code of 1, now it is not 1 to 1. Therefore f is not 1 to 1. If you take an element 2 in codomain, for which we do not find any pre-images in domain, means range is not equal to codomain. When range is not equal to codomain, clearly that function is not onto. So when the function is neither 1 to 1 nor onto, we will choose the option f is neither 1 to 1 nor onto. See, in the codomain if you take 2, in the codomain 2, where we do not find any pre-images in domain, we do not find any pre-images. If you take 1, we will have what? 1 to the power of 4 is 1 only, but f of 2 is 2 to the power of 4. Or you take any negative element in the codomain, for which we do not find any pre-images in domain. So like that you just give any one counter example, it is sufficient to say that function is not onto. Okay, only thing is to examine the function is 1 to 1 or subjective, find any one element in codomain for which its pre-image does not exist in domain. That is sufficient. Here we have one more objective question, where f is defined from R to R as f of x is equal to 3x. We need to choose the correct option. F is 1 to 1 onto, f is many 1 onto, f is 1 to 1 but not onto, f is neither 1 to 1 nor onto. Student, here we have one more type of functions like many 1. There also we find many 1. But we have not defined a many 1 function. We have defined only 1 to 1, onto and bijective. Then what is this many 1 function? Many 1 means when the function is not 1 to 1, then obviously that function is many 1. Which means you just find a trigonometric functions. Sin 30 is 1 by 2. Sin of 150 is 1 by 2. See, though theta is different, but its image is 1. Means different values of domain are having the same images in codomain, then we say that function is many one. Means many elements of the domain are having a same image in codomain. That time we will say that function is many one, nothing else. Okay. So now here f of x is 3x. If you take f of x1 is equal to f of x2, it implies x1 equals x2. Means satisfying the condition of injectivity or 1 to 1. Therefore f is 1 to 1. Like that, if you take y is equal to 3x, then x is equal to 3 by y. For any y belongs to codomain, we have x where it belongs to domain. Means satisfying the conditions of onto. Codomain is equal to range. Therefore, the function is onto. Whenever the function is both 1 to 1 and onto, clearly that function is bijective. That function is bijective. With that, we will conclude that problems on different types of functions like 1 to 1, onto, bijective. In the next class, we will discuss a different type other functions like composition of functions, invertible functions.
Subscribe now and press the bell icon. Never miss an update.